Section 1.3 deals with angles and how to measure angles and how to name angles. So we're starting section 1.3 right now, and you can see here that we have the definition of an angle, which is a figure formed by two rays or sides with a common endpoint called the vertex. So here we have an angle. This common endpoint has the vertex. If I don't advance to the next slide by mistake, sorry. So this common endpoint right here is the vertex. You can see it was formed by these two rays. We have ray RS and ray RT, and they have the common endpoint R to form the angle. So we can name this angle in a number of different ways. We can name it simply by the vertex. We can name it by the three letters that form the angle, so starting here SRT, or we can start here TRS. R, the vertex, is always in the middle when you're naming the angle using three letters, or simply we can place a number in the middle, in the interior of the angle, and call it angle 1. To measure an angle, we usually base it on actually starting with a circle, and we know that all the way around a circle is 360 degrees if you make one complete turnaround. So then we looked at how you would measure it if you had only half the circle, and you can see that something like this resembles what we call a protractor. So we're measuring the angles in degrees, where we're starting with 0 degrees over here and coming to 180 degrees over here, or vice versa, 0 degrees over here and 180 degrees over here, as opposed to going all the way around the circle. So we're going to talk a little bit more about how to measure angles with a protractor in the next couple slides, and we'll practice in class. So here it says, using a protractor, if we're going to find the measure of angle WXV. So angle WXV is this angle right here. Now we know that angles can be measured anywhere from 0 to 180 degrees. This is a small angle, so we're starting with our 0 here, and we're rotating up to this spot on the protractor. This side is in line with the 0, rotating up there, and that looks like it's about at 30 degrees. So we would say the measure of that angle is 30 degrees. Now you see there's two numbers here, the 30 and the 150. It's not 150 degrees because that would be a wide open angle, especially if this is 90. We're looking for the smaller angle here. If we were measuring from the other direction, say we were measuring YXW, YXW would be 150 degrees because that angle is much bigger than 30 degrees. So you have to pay attention to how big the angle is to know whether you're using the top number or the bottom number. So now if we're going to, so we should put here the measure of angle WXV is 30 degrees. Then if we look for ZXW, that's this angle here. So let's see if I can trace it in a different color. So ZXW is this angle here. Now how would we go about figuring out how big that angle is when neither of the sides actually lie at the 0 mark? So what we could do here, I know the measure of YXW, this big angle here, YXW is 150 degrees. And then I know that the measure of YXZ, this angle here, is 50 degrees. So if I take the big angle and I subtract out this here, then I have what's left, which is this here. So this is 150 degrees minus the 50 degrees for this angle. And so then I know that the angle that is remaining, ZXW, is 100 degrees. So we have many different types of angles, and we can name them by the measure or the number of degrees. If the angle is less than 90 degrees, from 0 to 90 degrees, we call it an acute angle. If it equals 90 degrees, we call it a right angle. If it's larger than 90 but less than 180, we call it an obtuse angle. And then an angle that is from 0 all the way here to 180, that is a straight angle because it forms a straight line. So just like we had the segment addition postulate, we also have an angle addition postulate. We talk here about, or here's a description of it, and there's a pictorial representation. If S, a point S, is in the interior of an angle PQR that you see here, such that you can draw a ray from the vertex through point S, so the ray is also in the interior of the angle, then what we're saying here is that angle PQS plus angle SQR, the sum of these angles will equal the big angle, angle PQR, and that's what we call the angle addition postulate. So if we take the angle addition postulate here, we can see that point F is on the interior of angle DEG. We know that the measure, that's what that little m stands for, of angle DEG, this whole thing is 115 degrees. And then it says the measure of angle DEF, see if we can get another ink color here. So DEF, this guy here, is 48 degrees. So can we use the angle addition postulate to figure out the measure of angle FEG? This angle here is what we want to find. And I thought I changed the color, but I guess not. So I'll just color it in. Okay, so if we set this up using the angle addition postulate, we can say that the measure of angle DEF plus the measure of angle FEG would be equal to the measure of angle DEG. Now we can substitute in what we know. We know that this angle is 115 degrees. We don't know the measure of angle FEG. That's what we're trying to find. And then we know that the measure of angle DEF is 48. So if you subtract 48 from both sides, we get the measure of angle FEG is, what would that be? 85 minus 10, 75 minus 8, what, 63 degrees, I believe. You might want to double check me on that, but I think it's correct. I'm here to say the two angles are congruent or equivalent. We'll put little angle marks here. This angle here is congruent to that one. And then we can see here, because of this green one, it's saying that angle LJK is congruent to angle KJM because of the green marks that they have there. So those two angles would be congruent. That means their measures would be equivalent. So we would say something like angle ABC is congruent to angle, they didn't mark this. Let's call this P. Angle DPF, or we can say the measure of angle ABC is equal to the measure of angle DPF. This says the angles are the same size. This says the measures of them are equal. So an angle bisector would be a ray that divides an angle into two congruent angles. So we want ray JK to be the angle bisector of LJM. So first I'm going to draw angle LJM. So we've got LJM, and I want JK to be a ray that bisects LJM. So we put K here. We can do ray JK. And what that says then is now we have created two angles that are congruent. This angle here, bad color choice. Sorry guys. See if I can choose another color that's better. So that means this angle here is now congruent to this angle here. Or you can put two little tick marks there saying that those two angles are congruent. So that means ray JK would be your angle bisector. Okay, so the angle bisector is equivalent to the midpoint. So if we know that KM bisects angle JKL, so we've got angle JKL here again. Oh, it wasn't JKL before, I guess. JKL here, and KM bisects it. We know that KM bisects it because it says it right here. So that means KM makes two equivalent angles. And I don't know why I keep choosing green when I know green doesn't write well on green. So we would say that this angle here is now equivalent to this angle here because KM is the bisector. It said it bisects it. So then it says JKM is 4x plus 6. JKM. This is 4x plus 6 degrees. And MKL is 7x minus 12 degrees. How can we find the measure of angle JKM? Well, if it's the angle bisector, that means it created two congruent angles, which means that their measures are equal. So we can say that 4x plus 6 is equal to 7x minus 12. Subtract 4x from both sides and we get 6 equals 3x minus 12. Add 12 to both sides and we get 18 equals 3x. And divide both sides by 3 and we get x is equal to 6. Now we have to make sure that we answer the question. It said find the measure of angle JKM. So JKM is represented by 4x plus 6. So we would do the measure of angle JKM is equal to 4x was 6 times 6 plus 6, which would be 24 plus 6, which would be 30 degrees. That's the measure of angle JKM.